Alright, so let's look at some of the features that make the combined gas law unique. The combined gas law actually combines pressure, volume, and temperature all into one large equation. And it's very important that as we go through solving this, we understand that pressure must be in ATMs, volume should be in liters, and temperature must be in Kelvin. And so let's explore trying to solve this using that approach and understanding. So, a small research submarine with a volume of 1.2 times 10 to the 5 liters has an internal pressure of 1 atms and an internal temperature of 15 degrees Celsius. If the submarine descends to a depth where the pressure is 150 atms and the temperature is 3 degrees Celsius, what will the volume of the gas inside be if the hull of the submarine breaks? So, even without decoding what this question is saying, I do see that there are 5 numbers given, which means that I'm trying to find that 6th variable. To solve for that 6th variable, we'll need to calculate using the 5 variables provided, being sure to make sure that they are in the appropriate unit format. Now, to simplify, I tend to put my variables found in the denominator in the numerator. So let me go about rearranging that equation to represent that. Rewritten, the product of P1 V1 T2 is equal to P2 V2 T1. And so essentially from there, I'm going to attempt solving the problems, being sure to make sure that my units are consistent. Now, looking at them, they are in ATMs. The pressure is in ATMs because I have 2 pressure conversions here and here. I'll represent that as P1 there and P2 respectively. P1 will be 1 ATM. P2 will be 150 ATMs. Next, I'm going to look at my T1 and T2. My T1 and T2 are equal to 15 degrees and 3 degrees Celsius respectively, which I'll go ahead and convert those to Kelvin. By adding 273 to each of them, which roughly ends up yielding 288 K, which is Kelvin, and 276 K, which is Kelvin. Alright, we have our V1 and V2 next, and one of these V's we're trying to determine. I'm going to assume in this case that we are solving for V2. So we'll put a question mark at V2, and V1 is represented by the 1.2 times 10 to the 5 liters, and we'll put that here. Alright, now I'm just going to plug away and try solving the problem using kind of algebra and multiplication and that kind of stuff. So let's go ahead and proceed. P1, 1 ATM, multiplied by V1, which is the 1.2 times 10 to the 5th liters. That's going to be multiplied by my T2, which in this case is 276 Kelvin. And I'm going to set that equal to the product of 150 ATMs, which is my P2. My V2 I'm not sure of because I'm solving for that. And my T1, which in this case is 288 Kelvin. And I will need a calculator to solve a question such as these. If I'm multiplying 1 times 276, it's going to be its own product. And I'm going to next multiply that by 1.2 raised to the 5th power. Well, times 10 raised to the 5th power. And that will yield a large number. which can then be compared to the numbers on the other side. $150 ATMs, V2, 288 Kelvin. Now, technically, if I was dealing with units, this would be ATMs times liters times Kelvin. It'll be simplified once we actually find our products. I'm going to go ahead and next multiply 150 by 288. It's going to yield this number. Now, you can round. There's no harm in rounding in this case, as long as you round to the correct number of significant figures. In each case, I believe for the left side, number 6 would have been 2 significant figures. On the right-hand side, it would have been 3 significant figures. So I'm going to next divide both sides by this number, this much larger number. And that will give me my value of V2 in liters. So here 3, 1, 2, 1, 2, 3, 4 divided by 4, 3, 2, 0, 0. And that's going to give me a value of 766.7, which I definitely am going to round that. Seeing as though this 1.0 ATM has the least amount of sig figs, I'm going to assume, well, actually the 3 degrees could be regarded as having one significant figure. So if we really were rounding it, a raw answer would be closer to 800 if you wanted one significant figure for liters. Or alternatively, you could use 2 sig figs, and if you wanted 2 sig figs, it would be 770 liters. I'm going to lean towards the 1 sig fig, and that's going to be my answer of 800 liters because I want 1 sig fig.